Hello friends, how are you? Today our topic is very electrifying. We'll be talking about electricity, which has dominated our modern world. We can't even think of a single second without electricity. Since you all are 10th grade children, so you might have come across few words in your daily life like electric circuit, electric charge, electric current and electric potentials. So I am here with you today. We'll be talking to you with all these simple words and we're giving you details in a very simple and easy way so that you can understand the concept very well and very comfortably. For that matter, I have created a very small and interesting setup for you. This is a setup which I have created, and now I will be giving you a brief of all these things just as an introduction. You will be surprised to know that there is a chain going on between all these four things which we use in our daily life. So let's come to electric circuit first. So what is electric circuit basically? So electric circuit, if you see this diagram, electric circuit consists of cells which are connected with a bulb, which are connected with wires and a switch below. So we require four things for an electric circuit to complete. These four things are cells. One cell is a cell. Two cells form a battery, two or more cells. So in this setup, we have got a battery with us, we have got bulb with us, we have got wires and we have got a switch here. So now we will do a magic. What are we going to do? We're going to switch it on. If I switch it on, you will see the bulb is glowing. So this is actually, I am completing an electric circuit. So this is electric circuit. Now you are being introduced with electric circuit. Now what is happening? What is flowing in these wires which is causing the bulb to glow? If you see, I am touching this circuit, I am switching it on. What is flowing in these wires which is completing the circuit and is causing the bulb to glow? This is actually a charge, and you all know charge flows through conductors, not through insulators. So actually these wires are made up of conductors, and these conductors can be copper or aluminium. But I can touch this wire very easily. I am not getting a short circuit. Why? Because metal is inside, outside is an insulator. Insulator, that is for us, that protect us from short circuiting. So second point is clear to you, that is electric charge. You are being introduced. So now what goes in a chain? I completed circuit, charge started flowing, and the third step was bulb started glowing. Why? Because bulb got a current. When the charge flows, current is produced. So third step is, I have got current with me. Okay. Now I told you these wires have got conductors. Then why do I require a cell? These are conductors, so they can always help the bulb to glow. Why can't they glow the bulb on their own? Because the electrons which are in the conductors in the valence shell, they do not get a push. Who gives a push? That push is given by these cells. So what do the cells do? Cells do some work so that electrons get a speed and they start moving like a charge and they produce current. So what do they produce? They produce electric potential. Yeah. Now we have introduced you with four things: electric circuit, electric charge, electric current and electric potential. Now let's come to these topics one by one again in details. So first of all, circuit. The circuit I showed you, let me put it in a diagram. So what I require for a circuit? I require a cell which has got positive terminal and a negative terminal. But here I use two cells, so I will use two cells here as well. These two cells, two or more cells, as I told you, they form a battery. So we have got a battery here. Now I connected these cells with the wire. Here comes a wire and here comes a gate-like switch. This is a switch and it is connected with a bulb. This is a circuit. Now I will make this switch is off. This is actually an open circuit. Open circuit when the switch is off and the bulb does not glow. So what happens? What will I do? I will close this switch. This is a gate-like switch. When I close this switch, now the circuit is closed and the bulb will start glowing. This is a bulb. This is a switch. These are wires. And this is battery. So this is my circuit. So as I told you, when the switch is off, current will not flow. When the switch is on, the current will flow and the bulb will glow. So circuit is of two types, open and close. And as I unrubbing it, as I told you, wires are made up of conductors, and those conductors can be copper or it can be aluminium. So, if the charge is flowing through the wires, can I relate it with a pipe where the water flows? No. Why? Because that pipe is hollow. But my wires are not hollow. I will show you the wire, how it looks like. It looks like a solid. Can you see it? These are copper wires that form a solid, and outside it is an insulation, so that we should not get a short circuit. So these wires are copper, aluminium, and insulators which do not allow the flow of current. They can be rubber, they can be plastic, they can be wood. But although rubber and wood is not used in wires, these are examples of insulators. So we use basically plastic in wires. So this point is clear to know. Now let's come to second point, and the second point is charge. So what is charge? Charge basically is of two types. Number one is static charge and number two is static electricity. We can also say that. And number two is current electricity. What is static electricity? Have you seen thundering? Have you seen if you rub a comb in your hair, it starts attracting piece of paper? But do you think that thundering continues to flow an electric current? No, that thundering is confined to that particular area which you can see through your vision. Even in comb also, that charge is confined to a comb. You cannot continue this charge to a next comb, then to a next comb. You cannot make a circle out of it. So that type of electricity which is confined to a particular region through the electrons, that is called as static electricity. That is, it does not flow. It does not flow. And example of this is lightning or rubbing of comb. So this is called as static electricity. But now we will be doing current electricity. So this is actually in your class, in your topic. So static electricity I am rubbing. Now I am giving you details of current electricity. What is current electricity? How does it produced? So every atom in this universe is made up of three fundamental particles and it has got a fundamental charge. What is fundamental charge, you will say? Like fundamental mass, charge is also a fundamental property. Fundamental means independent. Irrespective, wherever you keep the charge will remain same. Like my body has got a mass. Mass is a fundamental property. If I go to moon, even then the mass of my body will remain same. I go to any planet, any part of the world, my mass will remain the same. But my weight can vary depending upon the gravitational pull. Similarly, charge of any particular atom is constant. That is, it is a fundamental property. So it will not vary wherever you keep it. So when you talk about an atom again has got 3 fundamental particles. This you all know. What are these? I am talking fundamental as F particles. Can you guess? Like this, I'm making a structure of an atom. 1, 2. First shell has got 2 electrons, and second shell I am making maybe 3 electrons, which are the valence electrons. So what are these? These are all fundamental particles of an atom. So atom consists of electrons, and what is there inside the nucleus? It has got protons and neutrons. Protons, neutrons. Okay. Now, neutrons do not have any charge. We all know that. Neutrons have 0 charge. And the charge of electron is equal to charge on proton because their numbers are same. So, charge on electron and protons are equal. So, if you say an atom on the whole is neutral, then how does charge flows? Actually, I have got a comb for you. Like I rub my hair through, I'm combing my hair. So what will happen? Electrons, valence electrons of my hair will transfer to the comb. Comb will get negative charge and my hair will get positive charge. This is how the charge flows. When you rub any conductor, even the electrons, when they get a push, then only the charge flows. Not as such, if I am keeping a conductor, it will not produce any charge till the time I am disturbing it. So whenever I am rubbing it, my hair will get positive charge and my comb is getting negative charge, and thus the current starts flowing. So this is how electrons and protons, when they are imbalanced, so current starts producing and valence electrons start flowing. Now, can you tell me if charge has got any SI unit? Yes, the SI unit of charge is coulomb. Charge has got unit as C-O-U-L-O-M-B, coulomb. It is denoted by C. So, what is the charge on an electron? Charge on an electron is negative, that is minus 1.6 into 10 to the power minus 19, and I denote it as coulomb. And the charge on proton is plus 1.6 into 10 to the power minus 19 coulombs. So second point is charge. It is very much clear now. Charge is measured in coulombs and it is the flow of electrons. Okay, now it is clear. Static charge and static electricity and current electricity, as I told you, number of electrons, protons, everything is now clear. Now we will come to electric current. Now the next topic is electric current. For this, first of all, what is electric current? As I told you, when the charge starts flowing, current is produced. So, can I define electric current in terms of charge? Yes, that is rate of flow of charge. And charge, I told you, is it in coulombs? So electric current has got a numerical value. It has got a proper formula. So current, we denote it as I is equal to flow of charge per unit time. That is rate of flow of charge. That is, charge is as C charge by time. So if it is denoted by C coulomb, time is denoted by seconds. So current, unit of current will be coulombs per second, and coulomb per second is equal to ampere. We denote it as ampere. So what if I say 5 coulomb of current is flowing in 1 second? So what will be the 5 coulomb of charge is flowing in 1 second? What will the current? Current will be 5 ampere. So you have got numerical value of current. Now tell me, what is the direction of current? Direction of current is from positive to negative. Direction of current is positive to negative. Why? If I show you here, this is positive negative terminal and this is positive terminal of the Y of the cell. This is positive terminal. So the current will start flowing from positive to negative. Can I tell you why? Because electrons are negatively charged. So when I connect cell to the electrons, what will happen? These electrons will go and attract towards a positive terminal of the cell. So positive terminal of the cell will get maximum electrons. So they will start moving towards negative terminal. So that is how current starts flowing from positive to negative, and this is called as conventional current. But you know, there is one more thing. There is one more direction of current, that is called as electronic current. Though we do not use it. Electronic current is from negative to positive. Why? Because electrons are negatively charged. So negatively charged electrons, they say, are moving towards positively charged. But we will not use it. Why? Because when current was introduced, at that time, electrons were not introduced. So that's why from that day till today, we are using current direction from positive to negative. Now third point is, current has got, we have got a special instrument to measure the current, and that is called as ammeter. Ammeter allows to know how much current is flowing through a conductor at a particular time. So electric current is now clear to you. It has got a numerical value which is charge coulombs per second and is measured in ampere and is measured with an instrument called ammeter. So now I will come to last topic, that is electric potential. I told you, no, if I remove these cells, what will happen? Current will not flow. Why? Because the push to the electrons is not being done. Or I give you one more example. I have got a ball with me. As long as a ball is placed down, there is no work done and the ball is not moving. But if I have to push it, if I have to pull it up and then down, so I am doing a work to make this ball move from one point to other. So that work done by the cell to move the electrons from one point to other, that is called as electric potential. Very interesting. It has got two more names, potential difference or voltage. This is very common name which you might have known in your daily life. So electric potential or voltage. So can you define it now? What is electric potential or voltage? Voltage is V. It is equal to work done in carrying a charge from one terminal to other. So charge is in coulombs. Charge Q. Okay. So what is work done? Work done is in joules and charge is in coulombs. So if 1 joule of work is done in moving 1 coulomb of charge from one point to other, then voltage will be 1 volt. 1 volt. And what if I say 5 joule of work is done in carrying 1 coulomb of charge from one point to another? Then the voltage will be 5 volts. Okay, this is very easy. So it is actually, voltage is a push that allows electron to move and the charge to be produced. So you know, voltage, electric potential, as I have told you, V is equal to work done in carrying a charge from one point to another, and its unit is volt. We have got a special instrument to measure electric voltage, and that is called as voltmeter. That is called as voltmeter. So do you know how much is the voltage of this cell? It is 1.5 volts. That is why we can touch these cells very easily. But what are the main points where the high voltage is there in a house? It has got in our main switches, main boxes there, and it has got generator. And in India, every house has got a supply of 220 volts. That's why we always say, do not touch any switch with your wet hand. You might get a short circuit. But it varies in country to country. For example, if you talk about USA, do you know how much is the voltage in every house? That is 110 volts. So now, ending up the topic of electricity, electric voltage and all 4 parts, I would like to show you how ammeter and voltmeter looks like. So just have a look on this diagram. This is A for ammeter and V for voltmeter. So this is all for the day. Hope you have understood all the things very easily, and it has now given you a clear vision of actually what these topics are. For anything, please do write to me in my comment box. Do subscribe my channel, and let's keep on exchanging views with each other through the comment box. My email address is nehatalwar07@gmail.com, and my comment section is on down. Thank you so much for being with me today. Hope you liked my session. Thank you so much. Bye.